Here's a good free response where we're given a table of data. I always really like focusing on the variables that I'm given. So I've got minutes and temperature in degrees Celsius. So let's read this. As a pot of tea cools, the temperature of the tea is modeled by a differentiable function h. For 0 is less than or equal to t, which is less than or equal to 10, where time t is measured in minutes, and temperature, h of t, is measured in degrees Celsius. Values of h of t at selected values of time, t, are shown in the table above. A. Use the data in the table to approximate the rate at which the temperature of the tea is changing at time t equals 3.5. Show the computations that lead to your answer. So let's look at A first. A asks for an approximate rate. So approximate means we're not taking a derivative. We couldn't take the derivative anyway because I don't have a function. An approximate rate is just slope. It's just change of y over the change of x. And they want the approximate slope at 3.5 minutes. So I'm just going to find the change in my y. So 52 minus 60 over the change in my x. Okay, over the interval 2 to 5, because 3.5 is going to be right in there. Okay, so that's going to give me -8 thirds. So -8 thirds. I guess they didn't ask specifically for units, but I'll put that in anyway. Degrees Celsius per minute. They do not take off if you don't include units unless they say include units. You could leave it like that, or you could leave it like -2.667 degrees, or -2.6 repeating, whatever works for you. So there's A. B. Using correct units, explain the meaning of 1/10 times the integral from 0 to 10 of h of t dt in the context of this problem. Use a trapezoidal sum with the 4 subintervals indicated by the table to estimate 1/10 times the integral 0 to 10 h of t dt. The first part of B is will not be on the 2020 AP exam because it is an average value. If you recall, we did learn this year, but it's not going to be tested this year. This form gives you the average of the y values. So this would equal the average temperature of the tea in degrees Celsius per minute over the first 10 minutes. But again, that's not going to be on the 2020 exam. But the second part, estimating this integral using a trapezoidal sum, might be. So we should definitely go over that. So if we're using 4 subintervals, remember subintervals for trapezoidal sums or for Riemann sums, they do not need to be the same size. And in this case, they're not going to be. Here are the 4 subintervals from 0 to 2, 2 to 5, 5 to 9, 9 to 10. I cannot stress enough the importance of doing a picture. Just make yourself a picture. It's really going to help. Okay, so 66, 2 has a y value of 60, 5 has a y value of 52, 9 has a y value of 44, 10 has a y value of 43, and I'm making little trapezoids. Little trapezoids. Fun little trapezoids. Going for some color coding here. All right. So again, the integral of h of t dt is of course the area under this curve, and we are from 0 to 10, and we are approximating that by coming up with the area of each trapezoid. All right, and just because this problem threw a 1/10 out front, we're going to throw a 1/10 out front as well. Okay, so let's find the area. If you recall the area of a trapezoid, it's
one of the bases plus the other base, but divided by 2. In other words, the average of the bases. So this base is 66, this base is 60, average of the bases times the height. The height is this distance right here, and so that's 2. Okay? The area of this red trapezoid, well, it's this base, boink, plus this base, divided by 2, average of bases, times the height, and that's going to be 3. Hope you're appreciating the color coding. The area of this next trapezoid is this base right here, 52, plus this base, 44, divided by this height of the trapezoid, which is 4, divided by 2, the average of the bases, times the height, which is 4. Got a little carried away there. And the last one, my base is 44, my second base is 43, divided by 2, and then times that height, which is 1. Okay, so you're going to add all that up, and in terms of showing work, you have to show this work. You have to show this. You have to indicate that you have found the area of each trapezoid in some way. Okay? You can either do it on the picture, or you can write that whole sum right there. Either way, you have to show that on your piece of paper. The other thing that's important to show is that you're showing that this integral is approximately equal, not exactly equal. Okay? And then this is approximately equal to 52.95. Okay? Well, I shouldn't say this integral is approximately equal to 52.95. This sum is exactly equal to that. They didn't say to leave units here, but of course we know that we found the average value. So this represents the average temperature of the tea over the first 10 minutes. Okay, so that was B. Let's try C.
C. Evaluate the integral from 0 to 10 of h prime of t dt using correct units. Explain the meaning of the expression in the context of this problem.
C asks us to evaluate the integral from 0 to 10 of h prime of t dt. All right, well, this is just straightforward fundamental theorem of calculus, people. The integral of a derivative is h of t evaluated at 10, so it's h of 10 minus h of 0. It's that simple. H of 10, that's time 10. My temperature is 43. At time 0, my temperature is 66. So that gives me a negative 23. Now here, they say using correct units, explain the meaning. Explain means use words. So the temperature, you can abbreviate though, the temperature of the tea drops 23 degrees Celsius from 0 to 10 minutes, something like that. Okay? So you have to show this work. You didn't have to show the 43 minus 66, but you had to show this setup, h of 10 minus h of 0. You had to show negative 23, and then you had to explain it in words.
D. At time t equals 0, biscuits with temperature 100 degrees Celsius were removed from an oven. The temperature of the biscuits at time t is modeled by a differentiable function b, for which it is known that b prime of t equals negative 13.84 times e raised to the negative 0.173 t. Using the given models, at time t equals 10, how much cooler are the biscuits than the tea?
Okay, now we have biscuits. Biscuits and tea. This problem must have been written by someone English. So basically we are looking for the difference between h of 10, which is the temperature of the tea at time 10. So that's 43 degrees Celsius. So that's the tea. And I want to find then B of 10. That's going to be the temperature of the biscuits. All right, well, how am I going to find this? Fundamental theorem of calculus, people. My starting temperature is 100 degrees. The temperature is changing at a rate of B prime of T. So I want to turn a rate into an accumulation of change from 0 to 10 of B prime of T, dt. Recall, if you take the integral of a rate, that tells us how much my thing has changed. So this is the rate at which the temperature of the biscuits is changing. So if I'm taking the integral of that rate, that's going to tell me the change in the temperature. All right? This is all you have to show. You do not need, and in fact, please do not take the integral of that function, negative 13.84 e to the blah, blah, blah. Don't do that by hand. Put it in your calculator. Put it in your calculator, 100 plus the integral, 0 to 10 of, put your function in there. All you have to do is give us the answer. That's all you have to show. So B of 10 equals 34.18275, blah, blah, blah. Remember, you don't want to round until the end of a problem. Okay, now I'm looking for h of 10 minus b of 10. And that's going to give me, now you're going to round, 8.817. So the biscuits are 8.817 degrees cooler, degrees Celsius, cooler than the temperature of the tea. Oh my gosh, this is making me hungry and thirsty. I'm going to go make myself a cup of tea. I personally recommend Earl Grey. Delicious.